Hi guys, I'm Pat Kelly. All right, in this type of problem, they provided a graph for us for the function, and they're asking us to use this graph to find the domain and the range of the function, and then we'll also evaluate these four guys too. So let's start with domain and range. And domain is a set of all input values, or in this case, x's. Right? X is my independent variable. So in order to do that from our graph, what you're looking at is which x values do have a y value somewhere. So some kind of graph drawn. For instance, if I point right there, that would be like an x of 3. If I go up far enough, I do see that there's some graph there. So I'm looking where on the entire x-axis is there graph above or below. Now each of these two branches of the graph do go on forever. So my x's are going to be covered all the way out, negative infinity to positive infinity. But you do want to pay attention to little problem areas, like in this case, x equals 1. If I focus on x equals 1, when I go down, there's an open circle, and that means there's no graph there, there's no function there. However, if I go up, there is a dot there, so yes, x of 1 does have a corresponding y value. And so there are no places where x doesn't have a corresponding y value. Look for those though. So for me, everywhere is covered, so my answer for domain is going to be the entire real number line for x. So I could say negative infinity to infinity. As an interval, you're looking at that. Okay, so now for range, we want to get an answer for range, the counterpart always for domain. And this time then we're thinking about the y values. So back to the graph. In order to answer this type of question from the graph, you're looking at which y values. So all along my y-axis, I'm now going to travel to the left and to the right looking for where there might be graph. For instance, if I pick 3 on a y-axis, there is some graph to the left of that. Let's go down here to 0 for the y value. There is some graph to the right of that. And it really only becomes an issue for me down here. At negative 2, go to the left, go to the right. There's an open circle, which means no graph. So negative 2 does not have any graph, left or right. In fact, nowhere below negative 2 has graph either. So for my range answer, it's going to start at a negative 2 and then go up to infinity. Because again, these branches go up, up, up forever. So the y values forever up will be covered. And I always put the rounded parentheses around the infinities. But the negative 2, you have to maybe stop and think. Do you want square brace or rounded parenthesis? So the y value of negative 2, there actually is not graph there. So I want to put a rounded parenthesis, open interval, excluding the value of negative 2. Okay, good. Now in order to get these values, part A, B, C, D, you're looking at what the y value is in this first case when x equals 2. So from the graph, when x equals 2, looks like my y value, my function is actually right on the x-axis. So my y value is 0. You're done. Part B, an x of 1. So come to your graph. Here's an x of 1. You've got to figure out where the graph is at x equals 1. There's that open circle again. It's not there. We've got to go up to the closed circle, which would be a y value of 1. So this answer is 1. Okay, f of 3. X is 3. Where's the y value? That looks to me like it's right about 2. You're eyeballing it. This is not an exact science, but if your graph is drawn pretty accurately, I think mine is, that looks like it's a 2. Finally, f of negative 1. I go to negative 1 as an x value. The real question though is where's your y value? Where's the graph? So it looks like I got to go up, up, up. Again, I'm eyeballing it, but I think my graph looks pretty good to suggest that it's a y value of 3. So answer of 3, and you're done. Okay? All right, that's it for this one.